1 over x. We got natural log, so we got a good idea of trying u as our denominator if it was a little bit more complicated. So we're going to start here and do a couple of questions that have to do with natural log. And then I know you guys are just dying for some trig. So I'm going to show you the integrals for some of our trig functions. They are not nice, so we'll kind of look at them as we go. So how else can I ask you to take an integral? Wow. What words in this question tell me to integrate? Area. So we're going to find the area of the region bounded by the graph of that, the x-axis, and the line x equals 3. We don't really need to know exactly what this looks like, but I know I'm going to integrate this function. Anyone think they know the bounds? What did you say? One of them definitely is 3, and I'm going to tell you it's the top bound. You think 0? How do we know? All right. How can we tell when this guy meets the x-axis? I can set this equal to 0. So the numerator needs to be 0. Get x equals 0. All right. I claim this question needs U-sub. Do you agree with me?
Yes, for sure.
All right, there is a function inside a function. It's kind of like a function inside a fraction. So what would you guys set u equal to? Beautiful. All right. I remember we needed to do du. Anyone remember how to do that? Take a derivative. So what am I going to write down? Beauteous. All right, Herbie's going through my questions already. There's no 2 in my integral, so I'm going to move it to the other side. What is it going to look like on the other side? Perfect. All right, so as I go to substitute in, I'm going to personally put the 1/2 out front. That makes me happier. My du will be at the end. What is the x over x squared plus 1 going to look like once I substitute? Oh, I could try to do that. I was meaning like in terms of u when I try to substitute in. All right, so the x was part of my du, so I like the over u part. I'm going to throw 1 over u in there because our x was part of our du. So let me do some highlighting since that was helping. What? Oh, wait, hold on. I am not there yet, Herbie. You are way further than me. All right, so that x and that dx is that 1/2 du that I plugged in. The x squared plus 1 on the bottom is our u on the bottom. So there's kind of nothing in that numerator. Some people write this as du over u. You could certainly do that. Or if you just need a placeholder, you could put a 1 on the top. Yeah, exactly. Good what if question. All right, so I am very glaringly missing my bounds. Let's see if we can find them. So Johnny was reminding us that we need to plug those bounds into the u equation. So what new bottom bound do you think I'm going to have when I plug in 0? 1. What about the top bound? 10. Were those what you got earlier, Herbie?
Yes.
Sick. All right. How do I integrate this? I know the 1/2 is going to stay. What is the integral of 1 over u? That would just be if I plug this back in. Let's scroll up. What's the integral of 1 over u? Natural log. All right. So that one we have to know. That one is not allowed to be fuzzy in your brain. If you have 1 over u to the first power, you are going to see some natural log showing up. So natural log, absolute value of u. Again, the absolute value bars have to be there because we have to make sure natural log is only getting positive things plugged into it. Can I leave my answer like this? I got to plug in x squared plus 1. Anyone notice something about how I just wrote my answer? I did remove the absolute value bars. Am I allowed to? Why? X squared plus 1 is always positive, so I could remove them. If you didn't, what? Yeah, you could keep them if you want to make sure it's extra positive inside. But there we go. Yeah, or if it was just even like x plus 1 in there, I would have to keep them because depending on the values of x that I plug in, it could be negative. All right. I kind of just want to skip that one. I want to go down to here. Oh, you actually used them because I forgot them. Let's erase those plus c's. Let's throw these bounds on here. Wow, what a dork. I'm actually not going to plug the x squared plus 1 back in because I am going to plug in my bounds instead. Oh, thank you, Chris. I was just so excited we were doing natural log. All right, so I'm going to plug in my bounds here. Which bound goes in first? Natural log of 10. And here, just like we were just talking about, 10 is definitely positive, so I can plug it in. Then I'm going to plug in 1. Anyone know what natural log of 1 is? 0. So we get 1/2 natural log of 10. What? Why did I just change what we did so much? I totally forgot we had bounds on this question because I was so excited about the natural log. So instead of the plus c, I should have this notation, and then I should be plugging in my bounds, top bound first, bottom bound second. Yep, exactly. What's wrong? We actually never do. So because we transferred our bounds to be numbers that are associated with u, that's kind of like where we plugged in. Because we remember we plugged in those x numbers into this to get the u numbers. Yes, it gets a little notationally weird though, because I can't write this equation with the x bound still here because that is making it look like those are u numbers. So every time we do u substitution, we're going to change the bounds to match our variable of integration.
If it was 1 over x,
What?
If it was 1 over x instead of
If we didn't have these bounds, we would do what we originally did. Yeah.
Wait, why did you get 0 from?
Natural log of 1 is 0. This is. This part's 0. All right. Let's go ahead. I want to skip this problem and roll down to this guy, and then I'm going to show you a couple of trig derivatives. If we look at this one, this says solve the differential equation. Now we're going to talk about this lingo pretty much for the rest of the unit. We're going to start talking about what a differential equation is, how to solve one. This one's not too bad though, because we just have a derivative, and solving a differential equation wants us to get back to an original function. So how do you think I'm going to get from a derivative back to an original function? Yeah, I'm going to integrate. I'm going to take the antiderivative. So to get my function y, I'm going to integrate this guy, 1 over x times natural log of x. All right. I need some ideas. How the heck am I going to integrate this? All right. So questions that I usually ask myself, is the denominator just x? No. So that probably means I need some sort of u sub. What are your thoughts on what u should be? All right, let's try it. All right. How do I find du? All right. What do you notice about this derivative? X times natural log of x. Why did you say, oh my God, we would need product rule. So how does product rule go again? First, what's the derivative of natural log of x? We just integrate stuff 1 over x plus second is, y'all, I'm not feeling good about this. Derivative of the first is 1 dx. This is looking way too complicated, right? Because I'm supposed to see that in my integral.
I don't see that.
I don't see that either. So it's all right to choose the wrong u. This is not going to work. So now we need to choose something else. My guess would be we need to choose something smaller because that made way too big of a u. or a du. All right. I like your idea, Sadie. I want to show what Matt's idea would do, though, because it's actually really frustrating. If you do u equals x, du would be dx. Don't even write this down. All that's going to literally do is just change your variable. But I get someone every once in a while who does that and then gets really frustrated. So this, not a great choice, but I'm glad we got to talk about it. So, Sadie, what did you recommend? Let's try that. All right, so sometimes I want to choose something that's kind of complicated because I want to see something for a du. But the denominator here, it's just a little too complicated. So let's do natural log of x, 1 over x dx. All right, Herbie says he sees it. Does anyone else see it? All right, if you don't see it, this is what some of my BC students really like to do. They like to rewrite that fraction as 2 fractions. All right. We're kind of done trying to find what to substitute. So let's actually substitute this in. The 1 over x and the dx at the end, that's going to be my du. What will the 1 over natural log of x look like? 1 over u. All right, y'all, get ready for the fun. How do I integrate 1 over u? Natural log, absolute value of u, plus c this time because we don't have any bounds. And then I plug the u back in. What's the u? So we have natural log of x plus c. He's cute. No. So that's my function. It is. I had one on my BC test once, or I think a problem set that was natural log and natural log and natural log of x. They were not pleased.
Well, we don't have to simplify it.
You can't simplify it. So no. Yeah, you can kind of this section of stuff, you can kind of just let your answer be gross. Let's find out. Probably going to grow very, very slowly. Natural log of x is a pretty slow growing function, even though it does grow to infinity. All right, natural log, absolute value, natural log of x.
Whoa, what the?
Yeah, anyone know why there's a vertical asymptote at x equals 1?
Zero.
Yeah, because natural log of 1 is 0 and natural log of 0 is undefined. So if you look at this guy, it's like plugging in that asymptote into another natural. Yeah. Yeah. All right. I want to show you these last trig ones. I'm going to show you 2 of them, and then I'm just going to tell you the other 2 rules. These are, again, ones that you would probably memorize. When you're thinking of memorizing these integral rules and in the new notes that we're going to do, those integral rules, these are ones that can be like clear for this unit test. You'll probably have a couple of them. I know I'm adding a lot of integral rules here because they're all kind of really picky. As we walk towards the AP test, these can be a little bit blurrier. These ones aren't going to get featured all that often. And even when we hit BC, they're not really featured all that often as well. So let me grab my charger. Does anyone remember from pre-cal? Tangent is equal to a fraction consisting of 2 other trig functions. Sine, you do remember.
No, because you taught me that.
Oh, perfect. All right. Tangent is equal to sine over cosine. I'm going to show you how to find integral. I need to make a list of all the trig things that are like actually helpful for this class. And then tell the pre-cal teachers. That's a lie. They'll help me. Or I'll just continue teaching. All right. So sine over cosine. All right. How do you think we can do this question? U sub, you got the joke. Great. All right. What do you think U is?
Oh, I get it.
Good. A good choice when we don't know is the denominator. What does that make du the derivative of u? Is it sine or is it negative sign? Negative sign for derivatives. All right. I don't have this negative in front of the sine x dx, so I'm going to move it to the other side to hang out with my du. All right, could you try to substitute and rewrite your integral real quick? I'm going to give you a second to try it on your own before I do it on the board. Yeah, that's what I was going to do. So like Herbie's asking, I was going to put my negative on the outside, du at the end. What fraction am I going to have inside? Plus 1 over u. That's feeling familiar. It's important. So I am using the cosine x as my u. That's the bottom. And then the du on the top is the sine x dx. So I could put like du over u if you wanted, but a lot of people keep that du at the back end, and one's kind of just acting like a placeholder. That negative is also coming from there. So it's just coming from a placeholder because I need a fraction there. And if I don't put anything on the top, I need a kind of a 1 there just to keep it as a fraction. It's part of what I'm substituting in. So for sine x dx, I'm plugging in all of this because that's what it's equal to. What? X at the very end. All right, so when we integrate 1 over u, what function is going to pop up? Natural log, absolute value of u. I'm going to plug back in. What's going in for u? Cosine x. So if you want, you can memorize this one. It is on the list of integrals that most teachers would have their students memorize. But I don't think this one's too bad as far as like going and trying to figure out what it is with the rules we just did. Yeah, as long as you know that first fraction. Now, the one for cotangent can be done very, very similarly, except you would flip it. So it'd be cosine over sine. Because your sine would be your u and the derivative of sine is positive cosine, this one would not have the negative sign in front and would have a sine as your inside instead of a cosine. But you can do that one almost just the same. Now, if you want to know secant and cosecant, I'm going to show you the way to do this, but eventually you'd probably memorize this because knowing the trick at the beginning is basically knowing the integral itself, but it's kind of cute. So let's try it together. I'm going to multiply by a fraction. What I would like you to determine for me is the fraction I'm writing down equivalent to the only thing I'm allowed to multiply by if I don't have an equal sign, the number 1. So can you just make sure this fraction is equivalent to 1? It's going to be kind of big. Is it 1? So I'm allowed to multiply by it? Cool. All right. Why am I using this fraction? Because I know it works. We'll see. It's very cool. I'm going to distribute this into this fraction. Why? Because I know it works. How would you write secant times secant? Like secant squared? Do you see it already? Nice. You do? All right. Secant times tangent, I'm just going to write secant x tangent x. All right. On the bottom, I'm going to keep that secant x plus tangent x. Now, right about now, you might be like, I do not trust you. I don't like what you're doing right now. Yeah, I would agree. It is a little too much. So let's make it look simpler. I want to do some U-sub. Let's make it look better. All right, Herbie's getting really excited. Herbie, what do you, the bottom? Herbie, are you the only one in the room who knows your trig derivatives? Is that why?
I actually don't know what they are, but I know they are something.
Okay.
It's really good.
All right. Does anyone know what the derivative of secant x is? All right. Have I showed you the little thing Nina showed everyone?
No. I know where Nina got that from.
Where? The internet? What? Oh, you?
Well, my
The-
sister
the-
and I told Nina about it.
Okay. So the internet also has it. I'm pretty sure the first person I ever saw use it was Jessica Booker's older sister. All right. So if we want the derivative of secant, you use the other two on that line. So what's the derivative of secant? Secant x tangent x. If you want the derivative of tangent, you do the other stuff on that line. So what is it? Wow. Wait, that looks really familiar. It's the entire numerator. So you're telling me all of this is du? Isn't it? And all of this is u? Yeah, it's du over u. Or if you wanted to write it, 1 over u du. We've now integrated into this so many times. What's the integral of 1 over u? Natural log. Absolute value of u. You guys cool if I plug u back in right now? So at the end of the day, this one's probably just as easy to memorize as it is to derive this formula. Using your pattern making skills, what do you think the integral of cosecant x is? Take a second to think about it. I think you can look at the patterns and think about it. It probably has natural log in it, right? Yeah. All right. I like the idea of it being negative. All right. What do you think? This one had secant and tangent in it. Cosecant and cotangent. I would say if you're going to know any of these four, the tangent and the cotangent can be clearer in your brain. The likelihood of you seeing secant or cosecant on an actual assessment, even my test, is pretty small. I think I put one in the problem set just for practice. But if I put one for the test, I'm going to almost guarantee it would be tangent or cotangent, if that. Here's how you would use this. So we're just going to plug in. We're not going to actually evaluate the trig. Would this question need U-sub, secant of 2x? Why would it need U-sub? Because 2x, that would be my u. So my du would be 2 dx. And I'd 1/2 this guy to the other side. This will now be secant of u inside here. All right. Would my bottom bound still be 0?
Yeah.
Yeah, but that's conveniently because 2 times 0 is 0. What would my top bound be? Yeah, pi over 4 works, or 2 pi over 8. Here, I would do 1/2, and I would use my rule for secant. I used the u equation to find my new bound. So every time, I got to plug in. All right. Here, I'm going to use this creepy rule. So natural log secant u plus tangent u from 0 to pi over 4. Yeah. And we changed those bounds to be numbers that were associated with u. We don't have to plug the u back in here because we do have to plug in the bounds. Does anyone know what secant of pi over 4 is? We'll just leave it secant of pi over 4. No. It's the square root of 2. Does anyone know what tangent of pi over 4 is? We're going to need this later today. Easier. Easier. 1. Minus 1/2 natural log. Anyone know what secant of 0 is? 1. Anyone know what tangent of 0 is? Ooh, this one's natural log of 1. What's that? Cool. Yeah. Yeah. It is crazy. It's a weird number. All right, let's take a solid break. When we come back, we're going to do a very quick lesson on Arctrig. I think I'm only going to do like 4 problems at the most, 5 problems at the most. And then we'll just spend the rest of class looking at our problem set, trying to get some of those questions actually done and checked off. Let's do 5 minutes. We can do 4.
5 words. Don't listen. 5 words. Be great.
Y'all, we're so close to the end of the year. I can't believe it. Yeah, I was looking at my calendar the other day. Yeah. Mm-hmm. Mm-hmm. Yeah, absolutely. Mm-hmm. Yeah, let's look at the calendar. Got to figure out how we're going to review for the AP test. Who's taking the AP test? A lot of you? Do you think mixed review or topic by topic? What do you think? I'm always trying to figure out.
We're not taking the AP
Fair. That's fair. We will probably do just a lot of free responses because that's the scary part of the test. It feels bad. Yeah. I would love to. I would absolutely love to. Yeah. I was a nerd. Pretty hardcore nerd. Also, I had, yes, Miss Kaczmarski is my teacher, so obviously I got that. I don't know. I actually never asked her. She's very good.
What was your score with
In high school?
that? Yeah.
I took that in middle school, but I didn't like geometry very much. It was a weird class. I took geometry in Washington State, and they weren't as accelerated with math, so there were 8 middle schoolers in the entire district that took geometry in 8th grade. So they bused us to the high school, and we ended up in like a 10th grade remedial geometry class, and just got bullied for being 8th graders. Pretty much. I remember very vividly, there was one day a girl was talking about eating mayonnaise on white rice. We had a very long discussion about it.
You should have let it die.
I don't know.
Did she fail?
I don't know. I didn't really socialize very much in that class because we were getting bullied. No, we just quietly beat them. I also just wasn't. I don't like geometry very much. I wish we could teach it like integrated with all of the other math content. Don't blame teachers.
You put the notes on the board and then it was a copy of like.
Okay, that's not a good decision.
That was our lesson for the exam.
I've heard that name.
He did not.
Whoa.
He in a fight. Oh, yeah.
Ooh, I tried to interrupt what was going to be a fight once. Almost got hit.
Did you just use this situation?
Yes, but I should not have tried. Another teacher was like, never do that again. I was like, yeah. Yeah, I heard that did not go well for him.
He got knocked down, yeah.
Yeah. Fights are scary, man. Yeah, I was just trying to show a parabolas in real life video. It was like 2 minutes long. And then I turn around and two kids are like circling each other chest to chest. I was
In
like,
this class?
no, this is in my old job. What? The fight about? Oh, I was just teaching down in the Charlottesville area. It was not a good
I
situation.
feel like that was like a normal day.
I really don't know. There's definitely like different parts of Charlottesville. So the school I was teaching at had a lot of kids from like the more rural areas. So it's definitely a weird vibe. Yeah. It was a weird vibe, but I did my student teaching at the place where like their STEM academy was. So it was a different vibe. There's also a really new administration here, 1000%. When I started that job, they gave me keys, a textbook, and said, "Good luck." No one even gave me a tour of the school. It's bad. It was January when I got hired too.
Really?
Yeah, I got hired to replace a teacher that got fired.
They get fired.
Rumor had it she was seen incapacitated by students out.
Wait, that's it?
I don't know, because that wouldn't be.
Is she not allowed to like live a life? Okay, and have fun is.
I'm not sure what the details were. There must have been more to the story, but that was the story I got told.
Teacher seen just fired later.
To be fair, teachers are considered public figures, so you can get fired for kind of silly things.
Is it actually illegal to drive without shoes on?
That feels unsafe.
My mom told me that. I don't know if
I feel like when parents say things are illegal, a lot of the time they're lying. All right, so I kind of just want to give you a foray into some of this. I'm probably only going to do the first 5 problems because the 6th one is a little aggressive. Now, do you guys remember, and it's okay if the answer is no, the derivative of arcsine or arctangent? All right, some weird fraction. That's good enough for me. So the derivative of arc sine of u, we had our derivative on the top. That was like our chain rule. And this one had the square root and the minus sign. All right. Does that look kind of familiar? All right. This guy had no square root and a plus sign. So just like natural log, where we kind of have to recognize the 1 over x or 1 over u, these ones are going to be ones where we have to kind of identify what was a formula before. Now, these questions are really good, and we're going to see this in a second. When U-sub isn't working for us, we want to think of Arctrig as like maybe a next step. So these are not going to come up very often. You will see in my notes ever so slightly that this one is a little bolded compared to the other one. That's because I have a strong preference for arctangent over arcsine, because this one does some really cool things in BC calculus. So if you're taking BC next year, you will definitely see arctangent. It has really cool horizontal asymptotes. So when we start talking about infinity in BC, arctangent comes up a lot. Yeah. Pretty much. So our du, think about like du is the derivative of u. So that's kind of replacing our chain rule step there. Now, I'm not really going to go into why these formulas are the way that they are. Because 1, I don't think you really care. 2, we're not going to use them that often. If you would like me to do a video of why these formulas are the way that they are, definitely can. It's going to change ever so slightly because of this a and this u. So that a is a constant. And because that constant is in there, we're going to end up with some fractions going on. So this first one, do you think this one is arcsine or arctangent? Arcsine. So this is going to be arcsine of u over a plus c. So when we do these integrals, we're going to identify what u is, identify what a is, and then we're going to see if we need to use u-sub. That's kind of our steps. Yes. Mm-hmm.
So you notice it has a square.
Yes.
Does that mean that's normally like squared?
Yes, exactly. So when we had this guy, since we didn't have anything there, it was like a 1 squared. Exactly. Here, this one's slightly more complicated. It's because the derivative of tangent is something squared, secant squared, instead of the derivative of sine being cosine, if anyone cares. But this has a 1 over a out front, arctangent u over a plus c. So I like to remember, since the derivative of tangent's a little more complicated, we got this guy being a little more complicated. So let's try a couple questions. I want to show you my process for these. We're going to talk about some shortcuts, some things we can do. But the first big task is finding U and A. Now, I want to show you why U-sub doesn't work for a question like this, like the U-sub we knew before now. If you didn't know anything about Arctrig, what would you set U equal to in this question? Yeah, I would probably try 4 minus x squared, which would make du what? Perfect, negative 2x. Now I can deal with that negative 2 all day, but this x is an absolute problem. We had questions last class where we had like an extra x in the integral that we could solve our u equation for. If our extra x is here, there is nothing we can do to remedy that. So if that is the case, where you have an extra x in your du, you want to start thinking about Arctrig. So that's when we can do these questions. So I want instead to think about Arctrig. Now, do you think this first one is going to be arcsine or arctangent? Why? Square root. All right. So we're going to find out what U is and what A is. Keep in mind, kind of like Derek was noticing in these formulas, both of those things are squared in the formulas. So what do you think U is? X. Perfect. I'm going to take du here just to prove a point. What is du? 1 dx. So there is nothing that any sort of U-sub would change about this. I don't have to keep track of any U-sub. The fact that these are just the same, I don't have to worry about U-sub at all. Because this guy should be whatever U is squared, since this is just x squared, just x. All right. What do you guys think A is? 2. All right. So we said this was arcsine. Does arcsine have the 1 over a out front? No. So we're going to do arcsine of u over a, so x over 2 plus c. Done. Because this is a squared, so we have to find the square root. Yeah. Yeah, so we, like the question you had on the test where you had a point to plug in, and you found C, we're actually going to do a lot of that at the end of this. Remember these directions, the directions solve the differential equation. When we do that, we're going to be finding C almost every time. All right, let's try another one here. What do you, let's look at this. So U, A. Do you think this one's arcsine or arctangent? Perfect. Again, if we try to set U equal to the bottom, this guy would do 2x dx. I don't have that in the top. All right, what do you think U is? All right, so I don't need to deal with any U-sub situation here because I don't have any constants, anything to keep track of. What's A? 4. We want whatever made 16 when we squared it. What do you guys think I'm going to do with that 5? Yeah, just multiply it at the front. Arctangent, you said. Is that the one with the 1 over a out front? So I'm going to do 5 over 4. You could do 5 times 1/4. That would be fine. Arctangent of u over a plus c. So you're probably noticing this isn't super challenging. The challenging part is knowing when you need to use this guy. It does look weird. All right, let's do these last 2 and then one with bounds.
So one way to like find it is noticing that like all the numbers can be perfectly
a lot of the time they're going to work that way. I don't have to make it a perfect square, but I can. All right, this one. You think arcsine or arctangent? Probably arcsine. So what do you think U is? All right, it's coming from the 25x squared, but I don't want that to be my u. I want whatever squared I did to get that. So I like the 5x that I'm thinking of. All right. No, because the minus is part of the arc sine formula. Yep. So remember, arc sine has that minus in it. So we're just going to keep the 5x. All right, here, yep, Derek's noticing. Here I have 5 dx. Now, do I have that 5 in my integral? No. So I'm going to move that to the other side. I'm going to talk about this a little bit. I'm actually not going to do a full substitution because the only thing that's going to change is that 1/5. So we're going to throw that out in front with our a. Speaking of a, what do you think a is in this question? 4. All right. Arc sine, you said. Is that the one with the 1/a out front? No. All right. What will go out front of our arc sine? All right. The 1/5 is going to go out there. What else am I forgetting? The 2 from the top. So I'm going to do 2/5. So the over 5 coming from the 1/5, the 2 coming from the front. Arc sine, what will go inside? 5x/4 plus c. Yeah, it's not too bad. The fraction. So if I rewrote the substitution for this and actually did the u sub, I'd have the 2 on the top, square root of 16 minus u squared. And then when I plugged in du, I'd have that 1/5 out front. So instead of kind of doing that whole substitution, I can just chuck that 1/5 out in front in my final integral. If you want to rewrite it, absolutely fine. All right, last one. What do you think? Any thoughts? All right, probably arctangent. What do you think u is? Good. I like one thing I do want to point out. I wrote the x squareds at the end here. I want to point out the u is always the x part. So even if I wrote it like dx 9x squared plus 2, the u is still going to be the x part no matter what. That has our variables in it. What does that make du? 3 dx, and I'm going to keep the 1/3 over here. Now, I heard someone answering the question that I'm going to ask in a second. What's a? Good. All right, we want whatever would give me 2 when I square it. So I need to take a square root of that 2 to get square root of 2 times square root of 2 gives me 2. All right, you guys said arctangent. Is that the one with the 1/a out front? All right, so I have 1 square root of 2. Who's going to join that square root of 2? Yeah, the 1/3. So I'm going to do 1/3 root 2. Arctangent u/a. So 3x over the square root of 2 plus c. Am I going to rationalize those denominators? No. Rationalizing is for dweebs. Correct. I tried to come up with any reason that you would have to rationalize with another teacher, Miss Post, if anyone knows her. She's your assistant principal. The only reason we could come up with was for the unit circle. Literally it. So we never have to. All right, this last one. I am going to add in 2 values from the unit circle that I would like you to know. So these are arctangent values. I would like you to know what arctangent of 1 and arctangent of 0 are. Does anyone know what angle gives you a tangent of 1? Sine and cosine are the same value. That is actually right here, right in the middle. Does anyone know what angle this is here? What? All right, 45 degrees. In radians. How many radians? Perfect. Pi/4 radians. All right. So tangent of pi/4 is 1. So arctangent of 1 is pi/4. Those are inverse functions. All right. Anyone know where tangent is 0? Take your best guess. Don't think too hard. It's 0. All right. So add those to your factoids. I would like you to know arctangent of 1 is pi/4. Arctangent of 0 is 0. If you're taking BC next year, I'm going to make you memorize them then anyway. No. Tangent of pi over 2 is actually undefined. We can have a unit circle talk later. Maybe I'll try to find some reason. It's okay. Again, you guys tell me you did learn it at some point?
Well,
You've been lying to me all year? All right. Let's try to do this last question. This is the last one I want to do. All right. How do you think I'm going to do this question? Okay. Good start. Also a good start. All right. You think there's a U?
Yeah.
What do you think U is? Oh, so you guys are saying we're going to use Arctrig? Which one? Probably arctangent. All right. So 2x. So what's du? All right. So I'm going to move the 2 to the other side. Cool. All right. What else do we normally find? Oh, A. You're saying it's square root of 1 or 1? All right. Do you guys actually want to do the substitution, or do you just want to write down the antiderivative in terms of x like we've been doing? All right. So what? Oh, I missed it. I scrolled up. Oh. It didn't look weird here, though. All right. So let's go ahead and write our antiderivative in terms of x. So will I have anything out front of my arctangent? 1/2 from the U-sub. I usually have the 1 over a, but I don't have to worry about it too much because it's a is 1. So arctangent u over a, 2x over 1, so 2x. And how do I write down, hey, I took the antiderivative, but hey, I didn't plug in my bounds. Cool. Now, you'll notice I actually didn't change my bounds here like I normally do with U-sub, but that's because I never really did my substitution with U. We're kind of doing this substitution, if you will, in our heads. So that is allowed. We just need to make sure whatever variable we're using is matching the letters that I'm plugging in. All right, let's go ahead and we're going to plug in our bounds. Which bound goes in first? What's 2 times 1/2? Cool. 2 times 0. I'm smart enough to do that. Oh, look at these 2 values that I want you to plug in. Do they look familiar? 1. Here? So the only thing inside the arctangent is the 1. So it look like that. All right, so we have 1/2. Yeah, we can. All right, here I can put in pi over 4. And then Matt's noticing since arctangent of 0 is 0, this whole back end is 0. So what's our final answer? Pi over 8. All right, you guys done listening to me talk? Cool. Then I'm going to skip the last one. If you are feeling a challenge and you want to start comparing methods, one thing we're eventually going to have to do is choose what method we can use to do these guys. Does anyone see one that might work with the Arctrig we just learned? Let me number them. Ooh, 2 of them look like Arctrig. One of them's not. This actually isn't because of the minus sign. For the plus, this one's, which one is this one? Arctangent. You actually don't know how to do this yet. This might be one method I teach you after the EP test called partial fractions. No, it's not. It's on the BC test. You could do this one with U-sub. What do you think the U would be? Probably denominator. Oh, we did this one. Does anyone remember how we did this one? This was the one where the U was like, the du was like way too big. Not U was not just x. It was natural log of x. All right. What do you think about this one? This one's U-sub too. What do you think U would be? Never want to use just X. I would just switch our variables.
I don't log X over X.
We could actually just use natural log of X again, because what's the derivative of natural log of X? 1 over X. This one you can't do either. This would be the other method I would teach you after the AP exam. It's called integration by parts. If you've heard any of the BC students talking about OOV-VADOO. There you go. Yeah, they're a little weird. You can't. If you take math analysis, you can jump from math analysis straight to BC. It's a hard jump because math analysis doesn't make it super far into calc. And then I assume you know a lot.
Yeah.
The mean. At least meaner there. All right. What I would like you guys to do now. We have about 10 minutes left of class. I'd like you to grab out your problem set. The dates are on the board. I would like you to try at the front of your problem set. I think you are prepared to do a lot of the questions. You can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Everything up to number 14, you are capable of doing right now. I have an answer key. I would like you to try to get 2 problems done. I'm going to walk around with stickers and or a magic marker.
No.
If you get one right, I will either give you a giant check mark or a sticker for that problem. Does anyone else need a problem set besides this?
No.
All right. Try to get as much done as you can. Think of this as your notes check for today. So think of this as if you needed to get 3 problems done. Thank you. Next class, we start differential equation. Next class is going to be so easy. All right. Stickers. Shiny stars. If you're looking to do an Arctrig one, you can do an Arctrig one. Who can you find the Arctrig one? There's only one.
Oh, here we go.
Exponential growth in decay.
I know, I'm just asking, like, what is this?
Found the apocalypse.
I'm hoping for it not being popular.
That was not our time.
Me,
So
zombies will let
did
me
it-
live.
did I do it all right?
And
Because
you're
it's
fine.
Because it signs the fraction, or because it's arctangent, the fraction of
That's what I do. Distracted me actually.
You think in a zombie apocalypse, zombies would let me live if I could help?
I don't know, maybe you can consult cold freeze. Zombies and calculus.
If you turned into a zombie, would you let me
It's a
live if
real
I could
book.
solve some calculus?
I haven't read it yet.
Oh.
What's happening? Everyone's got it. Yes, it's always the expert, no matter which direction.
Is it? Meredith?
Yeah, that's great. Funny.
I think I'll finish it. This one.
I would be agree. So I was thinking to add one to the
Oh, and do that.
do your vertical bar.
And then do this.
I love like this.
That's why you did that on here. It's not a push that.
Derek. Yes, would you like a glittery star?
Yeah. Yeah.
you have a problem, right? Number 9. Oh, because of the end of all of yours.
Oh.
Yes.
Silly.
You have a question when you're ready.
If you don't like it.
Why would I not like one?
I don't know.
I've been kind of confused. Especially like when I'm recording here, so I know I'm supposed to. It's but then I'm not sure what it's like and how you get it.
Look at this part. Remember where you chose your U? That was inside the cube, right? So you're definitely gonna have a U cube.
Yeah, okay.
And then the rest of the stuff, your product squares and DX, that's all in the U, so that's covered by what you put.
Okay.
So that is what.
And so then I just.
Now you're gonna integrate this guy, and you'll have that vertical bar on the end of your bound. Then you'll plug in your bound. Johnny, that is what I got.
And then.
And look at that beautiful technology. Would you like to go back to color? Nice. I think this is just how we're gonna make it. Would you like to literally start?
Sure.
What
And
color?
now you're interviewing, so you're saying, here's your name.
How did you get your calculus juniors and seniors motivated to do their problems every day? I pulled out the sticks.
They're very
Oh, I haven't checked that one yet. This helps me grow. Ooh, make sure you actually integrate them cosine. That should be a sticker for them. Other than that, I think it's accurate. I'm just gonna stand here, so you're gonna fix that. Pretty much.
Yes.
What color sticker would you like? The red one. Ooh, no, because our integral of cosine is actually positive sign. Because the derivative of sine. Those signs are the worst. Sir, would you like a sticker?
Is the picture?
That one? Oh, I almost love it. Can you just plug your computer back? Oh, you did. I just didn't look. It's more motivated for this.
Yeah, this. Is this, is that right to say? I never used it.
Yes, I would just argue where you
Oh.
go. See that you have it. Oh, that
Can you
was.
put it up there?
Put it up there, put it up front. So, which one?
He's a swimmer. He's in water all the time.
Towards all general. So usually the first thing I'm gonna do is, think of it when you choose a rule, you wanna look for a function that's embedded. Side number 1, I'm gonna put stuff inside. For 5, for the stuff on the side, so that's 1. For weirder looking ones, like exponentials, your exponent is always a good place. For fractions, it's not always a good place to go.
Yes.
That's kind of the general. And then if the beam doesn't work out the way you need to, you can try smaller things, different things, pull that stuff out. Remember last thing, we got when we integrated for you? Derek.
I already got it.
You said
I got 7.
Seven. Oh, that's fun. Oh, wait. Oh, I hope it's Where's your, oh, I think you took a derivative instead of an integral. I would look at your notes from the other day, it's one of them. Hello.
I'm literally at
How
right now.
beautiful. Terrible. Because then I won't have to study you later.
so wait, now I'm going to
Plug in your bounds. Which one goes in first? Yeah. What? Sure.
What's it?
You also erase that negative sign?
Oh, yeah. Oh,
Yeah,
I was like, we're almost done. So notice how you have the X here with your GX? I don't have this anymore. So I would divide that 4 to the other side. So you can substitute
Like
1
that
and
God of
4.
War style.
So I kind of trying to
really want to. I don't know. It's fine. You can fit it. Go. Take your turn. You goofball.
All right, before we leave, please bring your problem set next time. I'm gonna try to build in some work time, probably at the beginning of class. And then we're going to do intro to differential equations and slope fields. Should be a relatively easy day of notes. Thank you guys for your hard work today, and I will see you on Friday. Will I grade these tests before next class? Where's my hand? Here it is. Happy Wednesday, everyone.
So for outreach,
Yes.
I did find something else to do.
Okay. I would just keep talking to the outreach team
Okay.
and
Yeah.
say, I'm really only involved once. I just have to send some emails at the end. So everything like approval wise is going through them.
So
Thank you, Miss
he
Duffy.
agreed to it and everything.
Sounds wonderful.
Yeah.
Sup, Nina? Sup, Sam? Do you want to start your test or not?
Yeah, I just thought about that.
Have you turned in your problem set yet?
I think I did. I have it. I should have it.
Okay. I can't. I've got a lot of people who have a lot of makeup work. Ma'am.
So I'm supposed to take the test,
Yeah?
but I can't take it during my early release because I have to take another test today,
Okay.
and I'm getting my wisdom.
Oh,
I have early release on.
yeah. Do you want to start it right now or do you want to just take the whole thing during your early release?
Can I just do the whole thing?
All right. Let me say hello to everyone. That's fine.
Okay, thank you.
I don't want you taking this test under any supervision.
Yeah.
Not a
I
good
got
idea.
I got it.
I could do it that Friday, but that's when I'm supposed to take the test. And I don't want to take the test.
Why do you gotta get every 2 tests?
Let's look at
Summer. Yeah.
I'm so scared. I'm literally like terrified about you. Really. Yeah. My dentist is like, you need air to get out. But I'm so scared.
Negative.
I don't want to do it at all.
I would be so scared.
They like put you to sleep, like put them back, and then you just like.
As long as it's not a shot.
Yeah. Yeah. I don't think it's a shot, but it's like. Yes, I don't want to do it. I have to do it. I've never done this.
It's the one
I don't
for.
so weird. I don't want
All
to
right.
do it.
I don't
It's just like going to sleep. Yeah, but still, like, I'm scared. I don't know. And I don't want to take it.
I literally texted him.
Yeah.
He told one.
Everyone
My
is
face is gonna be so swollen. I'm gonna like look at me like
I looked at the logs, bro.
like I'm not
Yeah, I
excited.
realized it after like 10 minutes.
I
I was like, oh, it's a fracture. Oh, am I screwed on that German?
Well, you can, but like, it's, I'm not gonna like eat like apple food. Like I feel like socks. So like apple sauce for like 4 days. I think my mom will be like, told my mom. Yeah.
I know, I bet. Yeah, I was thinking I did it translate before, but I like I thought. And then I woke up and I was
So like the remainder for 5
I
turns.
think that no gift was to make it
would
there.
be a-
So, and then so you just do.
Out of however many. Hello. Hi.
Well, do you want to say mine? You don't have to say mine. Oh, that's only for L. You say mine or?
I say,
You have no memory. Where's my phone?
Alright, let's again.
I don't know.
I guess.
Why did I put it there?
One.
Wait, I put my AirPods there. Why don't you?
Who's that?
Actually, it's not. Amelia's not here.
Amelia. 1, 2, 3, check it.
Yeah, I haven't seen that.
Oh, you can say like, will be.
Partial fraction.
Yeah,
Are you starting to study, or is this old?
This is old stuff.
Oh, nice.
Oh, the one over there.
Love that.
The kid.
All right. Oh, I'm still recording for my AV class. I don't need to record. Oh, we were doing a lot today.